Hi, we have the AP Physics 1 past paper 2023. We are discussing free response question section. In this question, question number 5 carry the 7 points. The question is a rod with the sphere attached to the end is connected to the horizontal mounted axle carefully balanced so that it rests in a position vertically upward from the axle. As shown in a figure, from the center of mass of the rod system is indicated by the cross sign. Here it is the center of mass is indicated. The sphere is lightly tapped. The rod sphere system rotates clockwise with the negligible friction from the axis due to gravitational force. So gravity come into action when we lightly tapped it started to rotate with clockwise direction. The student takes the video of the rod rotating with vertically upward position to vertically downward position. Fig 2 show the 5 frame still shots the student selected from the video. These frames are not equally spaced apart in time. Okay. Now this is the first, this is the second scenario, third scenario, fourth scenario, and the fifth. From vertically up position to vertically down position. We can conclude that. Use the frame of video in the Fig to answer the following question. In which frame angular acceleration of the rod sphere system is greatest? Justify your answer. So I have the answer C. C is that's the frame in which it has the greatest angular acceleration, means there is a greater change in velocity at that moment. Now justification why? Because the torque is equal to Rf sine of theta, there is only gravitational force acting this, so F can be replaced mg. Now, where is the theta? In this case, I said forces of gravity is acting along the center of mass. R is the distance from the axis to center of mass. Theta is the angle between rod and vertical gravity vector. Okay, at this moment the force of gravity is there, so angle we can measure is 90 degree. That's the sine 90. Sine 90 is the maximum at 90 degree. Now in frame A and E, the rod is vertical, gravity pulls straight down along the line of rod, so lever arm is zero, torque is zero. As you compare, the gravity is here, that's passing through the moment arm axis, so there is a R zero in this scenario. In this scenario is also force of gravity is here, that's also passing through the axis of rotation, so there is, in this case, R is again zero. And in this case, if the gravity is there, that's the theta, that's not equal to the 90, less than 90 you can say, so that's not give the maximum answer. So we have the angular acceleration is greatest, so we need the maximum torque at for the maximum angular acceleration. So we can say in frame C, horizontal rod perpendicular to the gravity, so there is a gravitational force at the maximum lever arm creating the greatest torque. Okay. The gravity creates the torque that causes the angular acceleration, changes the angular speed maximum. Tau is equal to I alpha, alpha is equal to tau by I. When tau is greater, alpha is greater, greatest torque result in greatest angular acceleration. Now, in which frame the rotational kinetic energy of the rod sphere system is the greatest? Briefly justify your answer. So, rotational kinetic energy greatest. So, answer is E. Why? Gravity does the work on a system as it falls. So, angular velocity keep increasing as long as the center of mass moving down. Okay, the angular speed is maximum at the lowest position, so kinetic energy is greatest when omega is greatest, angular speed is greatest, so we can say kinetic energy, rotational kinetic energy of the system is greatest when there is a maximum change, a maximum angular velocity, so kinetic energy is greatest at that moment. So in this case maximum work is there, so kinetic energy is work. We can also explain through work energy principle, when work is maximum kinetic energy is maximum. So in this case we can conclude. So next part of the question, rod sphere system M and the length center of mass is located at the distance 3 by 4L from the axis. Drive the expression in change in kinetic energy of the rod sphere system from the moment frame A to frame E. Express your answer in M, L and fundamental constant as appropriate. Initial position in a frame fit to frame A where center of mass is above the axle, so 3 by 4L. And the final position center of mass below the axle 3 by 4L. Total vertical drop we calculate H delta H at final minus initial. So final value is because it is below the axis, so that's the negative, that's the positive value. So below is there, that's considered by minus 3 by 4L. So our initial value is this one, change is equal to minus 3 by 2L. Now, change in potential energy, mg delta H, we have mg minus 3 by 2L, so minus 3 by 2 mgl is the total change in potential energy in this scenario. According to the law of conservation of energy, increase in kinetic energy should be equal to loss in gravitational potential energy. So we can say can delta K is equal to minus delta U is because there is a loss because it is vertically up to moving vertically down. So less height is there, so there is a loss in potential energy. So we can negative should be positive 3 by 2 mgl. There's the change in kinetic energy of the body. Now explain briefly why the rod sphere system gain kinetic energy if Earth is not included in a system. When Earth is not included, gravity is working as an external force. According to the work energy theorem, net work done by external force is equal to the change in kinetic energy. The as the rod falls, gravity does positive work on a rod sphere system because the displacement of center of mass has the component in the directional gravitational force. Mean theta is equal to 0, cos 0. Work done is equal to W is equal to FD cos theta. So we have FD cos of 0. So work is maximum, so change in kinetic energy is maximum. Positive work increase the kinetic energy of the system. That's the theoretical explanation why the system gain the kinetic energy. Okay, that's the answer. If you like the content, kindly subscribe and share it with your friends. If you have any query, kindly ask in the comments. Okay, take care.